This video will give you an overview of OzCAD's Detailer tool, followed by a detailed description of how it works and the various functions that it can perform. At the start you will see a list of chapters, each one followed by the time in the video that it begins. This will enable you to more easily scrub through to any particular part you might want to see. In this drawing from Kennedy Associates Architects in Sydney, we see a fairly typical set of details that you might see in a number of different projects. There's a lot of repetition in terms of elements like floor joists, rafters, ceiling joists, suspended ceilings, slabs, brickwork, and so on. And what we've done with the Detailer tool is to provide a lot of these sorts of items in a library that you can then put together in an assembly and much more quickly draw these kinds of details, either as a 1 to 50 or a 1 to 20 section, or as a more finely detailed 1 to 5 or 1 to 10 detail. We've also included in the tool a lot of the profiles in the Red Book as complete assemblies. So for doing ceilings, walls and floors, there's a lot of content in the styles that we've developed for the tool. You'll find the Detailer tool in the Detailing toolset, and this is the tool icon here. But let's start off by talking about the concept of the tool. So essentially, when you draw a detailer object, there will be a center component and then up to 4 additional left components and 4 additional right components. And here's an example of a detailer object here. So the center component here is containing a stud. In other words, if this was a stud wall in section, that would be a bottom plate, this would be a noggin, and that would be a top plate. And then there's also insulation in there as well. So that's the center component. Then the first left component are these battens, which are, I don't know, 42 by 42 or something like that. And then there's 13 millimeters of plasterboard on the outside of that. And it's the same on the left and right hand sides. Now if we double click the object, we can see where we make the choices for what goes into each component. So again, the left component, there were 2 of them. There are just symbols that are spaced, and the symbol is chosen here is 42 by 35. The second component is the plasterboard, and here it's just 13 millimeters, one layer of that. And it's the same on the right hand side. For the center components, the start object, in other words the bottom plate, is a 90 by 45. The end component, in other words the top plate, is also 90 by 45, and the stud, the noggin, is also 90 by 45. So that kind of builds up the object that you see here. In this case, the center component really isn't used. It's just a gap between the two. Then we have, I think they're shaft liners, and we've got some steel studs, and then some plasterboard. So if we take a look at this, we've got 4 components on each side in this particular one. We just move this over a little. So we've got the the shaft liner, which is the first component. We then just have a gap, we call that a nominated thickness, where you can just nominate the thickness of this component. We then have some symbols, which are the 64mm rondo studs, and then the plasterboard 13mm. And it's the same on the other side. And in the center components, there's basically, we're not putting any geometry in there at all. Now, in addition to being able to build these up like this, there are quite a few other options that you can choose. One of the useful ones is turning on this show component control points, and when you turn this on, you'll get a control point on each individual component, and that allows you to change the starting and ending positions of the sets of components within the object. If we do the same with this one, you'll see it's the same. So we can, well, you won't see much change on that end, but we can vary the components, and this way you can have one detail or object nicely overlapping another detail or object. We have the ability to turn off these control points because it gets very confusing when you've got lots of them. That's why that option is there. But once you've set those control point offsets, then they will be maintained if you change the overall length of the object. So if I move this up, the offsets that we have set are going to be maintained if I stretch this out or change its size. So let's take a look at a few more examples here. This object here is some corrugated roofing with a batten with some insulation, and the center component is just these rafters that are spaced at 450mm centers. One of the things you can do with this center component is to double up the start and end components. Now, primarily this was aimed at being able to do floor joists where you might double up the end joist at each end. And we can do that in the object info palette here. So this is the center component. So currently it's set to start single. So if we set it to start double, you'll see that we get the two joists there. But then I've got the ability to change the gap between those two. Currently it's set at 0. So if I wanted to, for example, put this second rafter here on the other side of the brickwork there, then I could enter, say, 120 as the gap, and I'll get that offset there, and then the 450 centers will be continued along the rest of the way. So what we have here is just this brick symbol that is being repeated. I guess one thing that's worth noting is that when you're creating the symbols, there's the assumption made that the object will be drawn horizontally. So by that I mean that if I take this object here and rotate this around to here, that's the assumption that the orientation is made when you're producing this actual symbol here. So this symbol here is a rectangle with a hatch, and then another little rectangle here that's slightly smaller in size, and that's just repeated. But when you're creating the symbol, you create it lying on its side like this. So for brickwork it's a little bit strange, but for things like joists it's kind of normal. So, and for these kinds of fittings here, it's kind of normal, but we had to make an assumption on that. So that's why when you open this up, this symbol here will be lying on its side, and you'll see that with the other masonry ones as well. So here are the various brick symbols that we've got in here, concrete blocks, concrete slabs, and so on. We'll look at those in a moment. And then we just, you might have here, this was going to be an opening, so we've created another little section using a brick symbol that just doesn't have any hatch in it and has a lighter line weight. And so you can just have this and use it as required around the drawing. For the suspended ceiling, this one is quite interesting because what we use with this allows us to change the drop of the suspended ceiling just by changing this number. Currently it's 200 being the length of this rod, but if I made that 400, for example, then this will drop down further. And if we take a look at that, we've got the hanging rod, we've got the hanging fitting at the top of the rod, we've got the rod itself, we've got the fitting at the bottom. Then in the center component we've got the various pieces needed to support the ceiling panels, and then the right components are actually a 1200 ceiling tile. This one's probably fairly self-explanatory. If we take a look at it, our center component doesn't have anything in it, and you can see over in the object info palette the center component is 20 millimeters thick. We've got a stud and some plasterboard on the left side and on the right side. With this one, our center component is the 64 millimeter studs, and they've been set up for the start, end and intermediate ones here. We've got a double plasterboard lining on both sides. On this side looks like we've got a rondo fixing clip, furring channel, and then the plasterboard, the double layer of plasterboard there as well. Yeah, this one's just a very simple one using a rondo quiet stud. This is a staggered stud, and we'll look into how to do this a bit further down the track, but you can easily do this kind of thing where you offset the studs so that you can get these gaps happening like this. Down here we've got LVL joists and particle board flooring. Again, here we've doubled up the first set of joists, and if we wanted to have a 40 millimeter gap in there, we could do that as well if there was a plate or something sitting on top of this. I mean, one thing you can do with these, you can just duplicate them and position them throughout. You don't have to try and define a whole detail by playing around with the numbers here. You can just duplicate it, and it's not going to use much more overhead because all of these are just symbols that are duplicated within the object. This is the same as this, but the section being cut the other way, so we're seeing the majority of the joists here in elevation. And again, if we look at that, the symbol we're using is basically just a symbol that has 4 lines in it, and those lines just get stretched out to create the pair of lines here and the pair of lines here. This example is included just to show you that you can use this for doing other kinds of details, like this might be a gate with some kind of spaced metal profile sitting on some framing here. And again, you're going to find a lot of these profiles are in there already. So these square hollow sections, so that's a 50 by 50, but there's a whole bunch of those in there. And there's also non-structural tube in various profiles and sizes as well. Over here to the rafters, this has the center component. In this one is the rafter itself, and we can change the rafter depth simply by changing this number here. So if it was a 140 rafter, we could just change that. That will jump up. We've got the sarking there, the battens. The actual symbol for the tile includes the batten. So if you look in here, you'll see that there's a batten here. That symbol. We'll look at how these symbols are constructed a bit later in the video. Similarly, this one, this is just provides an alternative approach to doing the sarking. In this case, this dashed line is actually part of the tile symbol. So the tile symbol includes the tile section, the batten, and the dashed line. And here this is just corrugated sheeting in side view, so that those profiles are all there as well. So let's take a look at the various component options, and you've probably seen the drop-down menu with a few choices in it: linear material, symbols at spacing, symbols at symbol definition spacing, symbols distributed, symbol scale to length, symbol scale to nominated thickness, and nominated thickness. So we'll go through each one of these separately to define what it is. The first one will be linear material. Now with linear material, the definitions for linear material are actually just wall styles. And we used wall styles because they provided an interface that was fairly compelling. You can control the line weights, you can control the fills or the textures of various components. So if you want to build up a single component, like I've done here, for example, this is just a fairly simple one with two different shades of grey, then you can do that very easily with a wall style. And just to remind you, if we look at the wall style, this is a wall. So down here, all of these items on the left-hand side are walls, and the items on the right-hand side are the detailer objects utilizing those wall styles. So, having a quick look at this wall style, you'll see it's just 2 layers of plasterboard, 16mm thick, and in here we can control the class and so on, and all of the attributes here in terms of the class name, the fill, and the pen thicknesses, and whether they're controlled by class will all come through into the detailer. So each of these things here is just a wall style, and then you can use these as a linear material in the detailer. So when you pick the linear material, you just choose the one that you want from all of the predefined ones, or create your own, or even use a wall style if you want to. Then that's just going to work, and what happens is that it will just get extended out for whatever length you define for that component. And now it's important to note that, as well as being able to do things like plasterboard and plywood and, particle board, or, whatever other kind of linear products you have, fiber cement, you can also do things like dashed line if you're wanting to show a membrane or something like this. And I'll just quickly have a look at how I did this particular wall style. So we'll edit wall style just off the bottom there. So what I wanted was, when I used this wall style, I wanted to be separated a little bit from the component on each side. So this wall style actually has 3 components in it. It has a 2mm air gap, and that component, everything is turned off. So this component is only being used to provide this 2mm gap. Then the actual visible component is a red line type, and here I've got a dashed line type set to 0.5, and then the last component is just another gap, which gives me that separation that I want on either side of the object. So this is what it looks like in the detailer object. But you can also use complex line type. So here, if this was could be a carpet or some other component that you wanted to show in an assembly, then you can use that. And of course, if you just use any of the conventional wall styles and pick them, they're just going to come through into the detailer object in exactly the same way as they were. But the thing to remember is that all of these wall styles get exploded within the detailer object, so there's no 3D geometry in the detailer object, and this permits the detailer object to be moved around in 3D. It's not a hybrid object, it's strictly a 2D only object. The symbols at spacing option is fairly self-explanatory. Essentially what's going to happen is that the symbol is going to be spaced with centers at whatever number is nominated. So here the spacing is 450mm, and you can see that the measured distance between each of these is 450 millimeters. Obviously, if we change this to say 300, they're going to get closer together and be 300 millimeters apart instead. The spacing will always start from the start end where the little arrow is, and if it's not precisely one whole unit, then there will be obviously a gap between whatever the spacing is and the handle at the end for that component. Now, there are a few little tricks with this spacing, because in some instances you might have battens or purlins running in a roof. So for example, if you've steel roofing, often the end span is required to be less than the center span. So for example, with corrugated sheeting, the center span is 1200, but the end span must be 900. And so we've added the ability to do that. And you'll see here there's this L1 or whichever component it is, adjust first last. So if I want to reduce the spacing on the start and the end here, I can do it simply by putting that number in that field. So currently it's 900. So if the overall spacing I wanted was 1200, but the end span was 900, I would set this to minus 300. And you'll see now I'm getting 900 spacing here, but then the intermediate spacing is 1200. Of course, you can use this in other ways to adjust this spacing. It might be another reason that you want to have two battens or two purlins or two studs or two joists close together, and you can use it for that. The final little example here, so this might be representing floor joists, and commonly with floor joists you're going to get the need to double them up at the start and the end, or both. And you'll notice that in this center component here, this is only available in the center component, by the way, you can see we've got start single, start double, end single. We've got all of the options here. So currently it's set to start double and end double. So we're going to get a double joist at each end here. And then you've got the ability to alter the gap between those. So typically it might be, these are 45 millimeter thick joists. So if I set that to 45, then I'm going to get that gap on here, and that will work if there's a wall sitting on top of this where you need to double them up. You can do that fairly easily. And as you drag this out, that double stud with that 45 millimeter spacing is going to be maintained at the end. And when this member here overlaps this one, it's going to drop that one out. So it's reasonably intelligent in that way. Symbols at symbol definition spacing. So this is a really useful one. You can take a simple portion of an assembly, for example, one corrugation or one lap of the sheeting, or one brick, or one floorboard, or cladding board, or one roof tile, and then the detail object is going to repeat those as much as you require. Now, the key here is getting the insertion point correct on the symbol. So let's jump into this symbol and have a look at where the insertion point needs to be for these symbols that are being used for symbol definition spacing. And you can see that vertically the symbol must be in the vertical center, and you'll see that up here with this little matrix here. Clicked on the center icon, the Y value must be 0. And be aware that it's possible for this to say 0 when it might be anything between 0 and 0.49. It will still display 0 unless you have your units set to display with one or more decimal places. So when creating the symbols, it's always useful to just select the Y value, type 0 and hit return, and that just definitely locates it in the center. It's not going to be half a millimeter out, and even being half a millimeter out, it can mess up the way the assemblies get put together. Then the start point of the symbol needs to be over here on the insertion point. So this is the insertion point of the symbol, and because this symbol is just going to get plonked up on here like this within the detailer object, the symbol insertion point is what needs to define that start point. Now in the case where you have an overlapping symbol, so if we have a look at this profile here, you can see that this sheet here overlaps the next sheet to be able to clip over that. And so the insertion point here is not going to be at the end of the sheet, but it's going to be somewhere around where these items overlap. So let's take a look at that. We'll jump into that symbol, do a fit to objects, and you can see that the insertion point for this one is back over here. And it's this line here will then define, so this line here will get put at the very end of the symbol, and that will allow this to align correctly. Sometimes when you're creating these, if they're not easy to create, you need to do a little test and measure the amount that it's not quite fitting by, then go back into the symbol and move it in the X direction to adjust that accordingly. Again, in the Y direction, the Y is set at 0. Let's take a look at the brick. So this is a fairly simple one. So we've just got a rectangle here with a hatch in it, and then a polyline here. And because we want the repetition to be on this point, that's fairly simple to define. Again, all of this one's not grouped, and you can see that we can't necessarily tell that these are correctly centered, and that's why if you group these like that, you then can check that the Y is exactly on 0. Now again with the floorboards, so this tongue and groove flooring is going to overlap a little bit. So let's take a look at this symbol definition, do a fit to objects. So you can see the insertion point here is in this groove, and when it repeats, the tongue is going to be almost into this point here. For example, it's going to essentially do that. So that little gap over here represents that little gap here. Again, the Y value is at 0. And finally, these roof tiles. These ones, some of them you'll find have got a locus point on the repeat point, just as a reference marker. So again, let's jump into this one, fit to objects, and again this is grouped to see that the Y value is correct, and then we've got the there's a line up here. I think if this line is possibly going to read a bit more a bit thicker. We've got the batten in there, and this is the repeat point here. So if I took this whole assembly and dragged it out, that point there would line up with the very tip of that tile there. So essentially that's how these work, and mostly they will work reasonably well at getting truncated and cut off as you make this smaller. The more geometry within the symbol, the more challenging it is to create this cutoff point correctly. So try and keep the symbol definitions fairly simple. You're going to see here that things like this are going to work fairly well. Every now and then you'll find that this just doesn't quite get it right, and you'll just have to adjust that point slightly in order to get it cut off correctly. The symbols distributed option is going to take your symbol and try to distribute it evenly between one end of the object and the other. So there's always going to be a start and an end one, or a symbol at the start and the end, and the distances between each one are always going to be the same. So this can be useful when you're trying to distribute evenly some members between, whether it's a sun screening device or a fence, or there are lots of instances where you actually want to distribute the components evenly. And so you can play around with the number here to actually get the value that you want. So if I set this to say 200, this is going to try and get it as close to 200. If it gets over 200, then it's going to put it more closely together in order to have an even spacing from one end to the other. Now you may or may not be aware that you can take any symbol, and on the left here we have 4 symbol definitions. You can take any symbol definition and actually stretch it. And when you try and do that, if it's the first time you've ever done it, you will get this dialog, are you sure you want to scale this symbol instance? If we go yes, then it allows us to stretch this out in any direction. It's still defined by the symbol definition, but it's a different size to the symbol definition. So with this option, what we do is we take the symbol definition and we stretch it out between the start point and end point of that component. Now, if you wanted to add something like just a cross between a couple of joists, you could use it for that. But it's probably more useful for doing this kind of thing. So this symbol definition here, well, let's jump in and take a look at what we've got with that symbol definition. And essentially it's just a polyline. Again, it's on the Y center. Now with all other symbol definitions, so we're talking about symbols that are not using the symbol definition spacing, the contents of the symbol must be at 0, 0 for the center of the symbol. And you'll see here that X is at 0 and Y is at 0 for this definition. And we've got a squiggly line along the top here. We've got a hidden edge on the start side and on the end side, and we've got another line along the bottom here. And by hidden edge, I mean that with the reshape tool, using this third option here, show or hide edges mode, when you click on an edge, you can make it show or hide. So we've got these two sides, the start and end one's hidden on this one. So if we exit out of that, when this gets stretched out, that very sharp, jagged line turns into sort of a more gentle, roughed edge. So if you want something that kind of looks like that, then you can use this method to do it. You might need a couple of different symbol definitions depending on how long this is, because as this gets shorter, the bumps get closer together and a bit more jagged. And as it gets stretched out further, they get smoothed out a bit. One of the nice things about scaling symbols is that this symbol, this one, and this one all have hatches in them, and the hatches are not scaled at all, they just fill up. So with this one here, there's just a little rectangle with that hatch in it, and that symbol definition just gets stretched out and that it just fills up with the hatch. Similarly with this concrete one here. Let's take a look at how this one was created. So again, it's similar to this one. The initial object is just a polyline. Again, it's got a hidden edge on here, a hidden edge on there. It's got a concrete hatch with a color. That gets converted into a symbol. The symbol definition, again, it's in the center. So over here, with the matrix set to the center, the X and Y are on 0, and that produces the result where it just stretches out the symbol. So these are really economical because you've got a very simple symbol definition, and this is just getting stretched out within the object. So from a file size point of view, scaling symbols to length is a very efficient way to fill an area with some hatch, image fill, or whatever you're wanting to use. Symbol scale to nominated thickness is essentially allowing you to take a symbol and to stretch it in height, or I guess in width if it was a wall or something like that. So in this case here, the initial symbol is a 90 by 45 symbol, and you'll see with this option, symbol scale to length, we've chosen a 90 by 45 symbol, and yet it's displaying at whatever thickness we've got set here, which is currently 200. So you'll see if I increase that to 300, then it's going to stretch the symbol out to that thickness. So you'll find as you start using the tool, there are instances where this can be quite handy. In this case here, we're taking this symbol, which is again 90 by 45, and basically it's stretching it out. So you're getting something that is this dimension here, which is the thickness 200 by 90 to get that sort of size. And in this case here, where the symbol is just a very simple rod for suspended ceilings, and this is how we can adjust the length of the rod using this thickness value here. Currently it's set on 500, So if I set it to 300, the rod length is going to change. Nominated thickness is a fairly simple concept. Essentially, you can just choose how thick a component's going to be. It's not going to put any geometry in there apart from drawing a fill and putting a line at the top and the bottom. If you're not using class attributes, the attributes of this object will be controlled by the attributes palette here. So if I change the fill color, it's going to change it. If you want to control nominated thickness by class, then there is a special left nominated thickness class and right nominated thickness class option that you can choose, and in this case I've chosen a class called nominated thickness example, and that class is set to have a yellow fill and some dashed line on the top and the bottom. So you can separately control the attributes of the nominated thickness for left and right. In a new blank document, if you place a detailer object, essentially this is what you'll get, something that just looks like a rectangle with a single handle at each end. The thickness of this is controlled here in the object info palette. So if I change that, the thickness is going to change. You can also alter the start and end angles. This is primarily useful if you're using this to represent a rafter in a roof where the object itself might be at an angle. And then you can add various other things to this as well. And it's probably easiest if we look at this in the components dialog. So I'll double click this. So here we have center components, and we can choose to have a start single, start double, end single, end double, and so on down the list here. So what do all those mean? Well, in this case here we have chosen what I think is a 140 by 45 joist, and we've set that to be single start and single end, and you'll see that in this pop-up here as well. Single start, single end. Here we've got a double start, and we've also got some intermediates. Here we've got a double start and a double end and some intermediate ones. And here we have a double start with a space between them, and the end ones also with a space between them. So if we say look at this one in the components dialog, you can see here's our start double, end double. We've chosen the two symbols that we want to use for those, and the intermediate symbols are symbols at spacing, and we've explained what that means. So that's how you can build these up. Same thing applies here. We've got the case of a wall in section, and we're just using the probably 90 by 45 studs with a top and bottom plate and a lining on either side. If we have a quick look at that, you'll see the linear material here is 10mm plasterboard. Over here it's 10mm plasterboard, and in the center we've got our 90 by 45 studs. Now you also have the ability to rotate these components, and while that's not necessary when the symbol definition is uniform like a stud would be, or a floor joist or something like that, when you're talking about a C section or a C purlin, then you need the ability to control which direction these are facing. So if we look at this one here, you can see that our first one is not flipped or rotated, so it's going to appear in this orientation, but the end one we have it set to flip horizontal, and so it's going to flip this around, and that's how we get this last member here being the other way around. If we were to flip the intermediate ones, for example, so if we said flip horizontal, then all of these ones are going to face the other way as well. But you can also rotate them as well as flipping. So here the intermediate ones have been rotated right 90 degrees. So the options there are left 90 degrees, right 90 degrees, 180, flip horizontal, flip vertical, flip horizontal, and vertical. And you'll find that there are different cases where you want to use all of these. You know, often, for example, in a tiled roof, the tile might be designed to go on a roof that is angled this way, but you've drawn it down this way, and the tiles are running the wrong way up the roof, and so you can use that process to flip them around accordingly. I've touched on this before, but let's just run over the symbol creation options. So generally when a symbol is just being placed and you're not using the symbol at symbol definition spacing, then the contents of the symbol want to be at the center or the insertion point of the symbol. So let's quickly take a look at these 4 symbols down here, and if we jump into this one, you'll see that the center of this is at the insertion point of the symbol, and it's always worth coming in here and double checking this and going 0, 0 when you're creating the symbol, because you can have, you'll notice here if I set this to point 0, 2, this is actually slightly off center now, but this is still reading at 0 because I have rounding set to 0 and I'm not showing any decimal places. If I was showing decimal places, I would see that this is actually not at 0. So it's important that when you're creating a symbol and you want these to be at 0, you need to actually type 0 and 0 in there and just tab them in and make sure that the object is exactly in the center. And grouping the entire contents of the symbol makes that a lot easier. Similarly with this one, you'll see it's also at 0, 0, and this one is a polyline with some, this one's going to get scaled in the left and right direction, so this will get flattened out to some degree. So the amount of roughness at the top of this polyline will determine how smooth or rough the stretched version of this is. With hatches, when the object is stretched, the hatch doesn't stretch, so it just fills accordingly. Again, this is in the center. And finally, here's a sample of some concrete slab. And if we jump into that one, it's literally just a polyline with the left and right edges hidden so that it's only drawing a line at the top and the bottom. And this will get scaled out to whatever width is nominated in the detailer object. For the custom insertion point, so this is where you're using the symbol definition spacing to define how these are replicated. And again, if we jump in here, so this one is just replicated end to end, so the very end of this is going to be at 0, and if we select it and I click on this little left icon here, you can see that the X is set to 0 and the Y is set to 0, and this will just get replicated in that fashion there for whatever length is defined in the detailer object. Similarly, in this object it actually overlaps, so that what will happen is that this insertion point here will run all the way down to the edge of this object here, so that when this gets duplicated in a detailer object, if we click on the insertion point, which can be a little bit hard to pick up, then this is going to get taken out and put right on the edge of that there. It's difficult to pick that up, but essentially that's the relationship that it has when it's duplicated. Sometimes when you're creating these, you'll set this up and you'll think you've got it right, then you'll go out into the drawing and you'll realize that the overlap is slightly out, for example. And what you can do is in the drawing, if you probably turn off zoom line thickness, if you measure whatever the offset needs to be, you need to bring this back 2 millimeters or something like that, measure what it is and go back into the symbol and just move it 2 millimeters to the left or right or whatever you need to do just to get that replication distance exactly right. Again, this one is a fairly simple one. It's just being replicated from the left hand side. So if this was grouped and we have the left center option selected in the little matrix here, X and Y are going to be 0. Similarly with a floorboard, so that symbol insertion point is going to run out and touch the end of this tongue here. And likewise, with a lot of these more complex symbols, we actually include a little locus at the insertion point of the symbol, and that just makes it a little bit easier to test and to work out that it's all working properly. In this case, I know that if I pick this up, click on that locus, bring that locus out to the very edge of this, then this is going to be the precise replicated distance that I need. When you do create a symbol, you will see that there is a folder called Detailer Symbols that's created in any file that you use the Detailer tool, and that's where you want to put your symbols. So if we have a look in that folder, you'll see this contains all of the symbols. These other objects are Detailer styles, that's why they're red. And if we revert this to just viewing symbols and plugin objects, we'll see just the Detailer Symbols folder plus all of these red objects, which are Detailer styles. We have the ability to add Batt insulation and Sarking to the components within a Detailer object. So let's just take a look at how this works. In the first case here, we have added some insulation in the component where these battens are. So if we select the Detailer object, this would be the left component 1, and you'll see here that L1 insulation is set to Batt and the insulation position is set to align left. And so the edge of the insulation is aligning to the left edge of that component. With the alignments, you have the ability to align center, left tapered, right, and right tapered, and we'll look at what those mean in a moment. Or you've got the ability to just match the component thickness. So if I set it to this, the component thickness is actually the thickness of those battens there, which I think is probably 35 millimeters or something like that, and so the insulation will just fit in there. Now this next one is the tapered option. So with this, you'll see align left tapered. So what it's going to do is to squash the insulation up as it goes over a purlin or a batten, as you can see here, or as you can see in this one here. The next one adds sarking to the bottom of that, and that's also an option here. So you'll see in L1 insulation you've got Batt plus reflective foil or reflective foil only. So currently we've got it set to that. And with either the Batt insulation or the reflective foil, you can set the attributes of those using these two pop-ups here. So here the insulation Batt class, currently it's set to none. You'll see if I change this to the Batt insulation detailer class, it can be any class you like. This class is actually set to have a yellow fill with some transparency, and it lightens up the insulation a little bit. The reflective foil class, yeah, that's just another class that we've created that has a dashed line style, it's red, and a slightly thicker line. So you can control the attributes of all of those sorts of things. Now when you set the insulation, and here the insulation is in the center component, I've got it set to match component thickness. Currently the component thickness is 90, but if I set that to 120, the insulation is just going to match whatever the thickness is. This one here, the center component, again is being used, but it's set to align center with the 50 millimeter thickness. This one here is again 50 millimeter thickness, but it's align left. This one is align right. And finally, just to indicate, you can add insulation to multiple components if you want to see this. So this one has the component 1, it's set to Batt plus reflective foil, and it's align left tapered with a 50 millimeter thickness, and then in the center component we've got Batt insulation align right with a 65 millimeter thickness. Let's recap now on how we can control the attributes of objects within a detailer object. So we have symbols, we have wall styles, we have components themselves. By and large, you can control things using classes, and we talked about with the insulation. If we look here, you'll see that this insulation is being controlled by the insulation Batt class nominated here, which is Batt insulation detailer. The reflective foil is being controlled by the reflective foil class. And that's pretty simple. You change the class attributes and these objects are going to change. Now sometimes you will find that when you do change some class attributes, the detailer object doesn't immediately update, and that's why we have these update buttons here. Update selected, update all. And if you've been playing around with attributes and you find that those attribute changes are not flowing through to the detailer object or all the detailer objects, you can use these two buttons to update them without necessarily having to come to each one and open the dialog and click OK or something like that. Now with symbols, you're going to find that that they're just going to take on whatever attributes are given to the objects within the symbol. If the symbol's components are being controlled by a class, then that's what will control the attributes. So if we jump in here, have a look at this symbol, go into the group, you'll see this is in the component timber framing class. And so changing the attributes of that class is all you need to do to change the appearance of these joists or studs or whatever they are. Similarly with wall styles, if you've defined a wall style that's being used in here and you're using classes, then those classes will control the attributes. If there's no class attributes, then just the wall style directly will control the attributes, so you'll need to edit the wall style to change the attributes of the linear materials that you're looking at. Now this particular object here has two nominated thickness components. Let's just jump in and have a look at this. So you'll see that the left one component and the right one component are set to nominated thickness. Now in the absence of giving these a class, they will just take on the attributes of the overall object. But once you give them a class, then they will take on those class attributes. And you'll see here there is another option for left nominated thickness class, and we've got that set here, left nominated thickness and the right nominated thickness. So that way you can use classes to control what happens with the nominated thickness components if you're using them. When using the detailer tool, you'll need to be familiar with three different kinds of resources that are available for the tool. The first are the detailer styles, and these are the predefined styles that we have created to get you going with the tool. We'll look at these again in a moment in greater detail. Then we have the detailer linear materials, and to find these they will be in the Vectorworks library's defaults detailer materials, and then you'll see a number of subfolders in there for the various different categories of objects. And then finally the detailer symbols, and again you'll see these in Vectorworks library's defaults detailer materials, and then you'll see the various subfolders where they're all broken down into the various categories. Now the last two that I mentioned, the detailer symbols and the detailer linear materials, you will always access from either the symbol pop-up in this dialog, so you'll see here Vectorworks libraries defaults detailer materials, or for linear materials the same location, defaults detailer materials, detailer linear materials, and there they are and there. So this is where you'll actually access these predefined symbols from, or if you add to these libraries, that's where you'll be accessing them from. Now just to give you a quick run through of the detailer styles that are shipping with the product, let's just select the detailer tool, click on the active definition pop-up at the top here, and here we are in object styles, detailer styles. The first folder is just the symbols that go to make up these styles, so not really useful here, but there are the floors, and there are LVL floors and concrete floors and timber floors, lots of different combinations of things there. We have the Gyprock CSR ceilings, so ceiling, and you'll see that a lot of these have the number. the ID number from the red book. If you want to see the full name, you can just hover over them. So you'll see that one's HEB 1604. And a lot of these will have either end or side or section or plan or some indication of whether this is created for a plan, a section, an elevation or a section as well. So if we hover over these, you'll see that one says end. You can also see these in list view. If you click up the top here, you get the full end, so you'll see end, side, and so on. End, side. So when that's applicable, you'll see those names there. With the roof, again, you can see the names there with various combinations of them. Then we've got the walls, exterior walls, so steel frame. Again, here you've got section and plan at the end of the name with the code number. Steel girt, and then the timber frame walls in lots of different combinations. Then interior walls, so interior frame walls. Again, we've got the plan and section indicated, and the interior timber frame walls. There's metalwork. That's just an example of something you could do if you're building a steel fence. And with the roofs, then there's tiled roofing. Again, end and side you'll see in there. So that would be an end view, that would be a side view. Filter sheet metal, so nail strip, neo-Roman and so on. And then Lysart, clip block, custom orb, spandex, etc. And there are some we've been experimenting with a little bit here, which are just some sections through some of the common aluminium commercial doors. So the final thing I just wanted to cover in this section was if you want to create your own library of objects. So what I've got here is a section through a roof. It's a 10mm pitch with some corrugated sheeting and insulation. So let's say this is a common combination of elements that you would use, and you'd like to save this as a style. So to do that, all you need to do is to come up here to the Style menu, and you go New Plugin Style from Unstyled Plugin. You get to choose where it gets saved within the document. Then you can click OK, and you can give it a name up here and change any of the settings. Presumably by the time you got to this point it would already be set up how you wanted it, and then you just click OK and it will get saved in the active document. So I'll just put AA in front of this to make it go to the top of the list. So we've saved this as AA Detailer Style, and if we then take the Detailer tool and we go to Open Files, and there is the one that we just saved, and it's available then for use in other documents. To finish up, let's just go over a couple of other features that we have in the Detailer tool. The first one is that we have integrated break lines in the Detailer, and you access these from the break lines option in the Object Info palette. You can have up to 4, and when you add them you'll get the ability to choose the type of break line that you want. And there are 6 types of break lines. There's a start, center and end, and these ones are the traditional kind of squiggly line break line, and then there's just the narrow, regular and wide break lines, which are essentially just white filled rectangles that will obliterate a portion of the unit. So in this one here we've got a left, center and right break line, and each of these has their own control line. So when you add a break line, the control point will appear. Similarly with these ones here, we can drag them along. And these will grow or shrink as required if the assembly gets quite wide. They are defined by symbols, so you will see in the detailer symbols folder, the brake line symbols are in here. So if you want to change the appearance of these, the line weight or the color or whatever, you can do that. So these are the ones that just have the rectangles, the white filled rectangles in them. The next thing I wanted to mention is that you can change the control line position. So when you draw a detail object, by default it will draw along the center line of the object, but sometimes you might want it to draw in relation to a specific component in the object, or along one edge or whatever. And this is similar to how the wall tool allows you to set, what control line is being used. So the detailer tool has that ability as well. And an example where you might use this is, for example, in suspended ceiling, I've got the control line set to this edge up here, so that I would typically come along and I'm drawing my detail and I want to put in a suspended ceiling, then I can just draw along the underside of the slab or the rafters, whatever it is that's supporting the ceiling, and this is going to drop down from that point. So you'll see, let's actually pick one of these that doesn't have. So the control line on this one is on the left edge of the center component, but you'll see that if I change that to, say, the outer edge of the left component, it's going to change to be right out there. Now these four down here just illustrate the offset ability. So there are two ways that we can offset components. Let's have a quick look at those. So sometimes you'll want components to overlap one another, and this is a case in point. So you would set this up here with these staggered studs. You set it up as though the studs are not staggered, and then we can push the studs back over the area where we want them to go. So if we take a look at this, it's fairly simple. The center doesn't have any geometry in it except for the insulation. We've got 64 millimeter rondo studs, steel studs on both sides of that center component, and then we've got 2 layers of plasterboard. So what we want to do is to push this stud here back down into this area here, and we can do that with this L1 offset here. The stud's 64 millimeters, so if I put minus 64 in there, and the same here, minus 64 in here, it's going to push this stud down to here and this stud up to there. You'll see when I click OK, then that's what's happened here. And it's a similar situation here. The studs are just timber studs, but I think these are 70 millimeters, so I'll just do one of these. If I do minus 70, you're going to see that it pushes that back down. So that is the way that you can overlap things, and that's also been used in this one here, where you want this symbol here, or this component, which is actually comes down to here, overlaps the this supporting member here. And if we have a look at that, you'll see that it's offset by minus 17 millimeters to enable it to appear overlapped over this bar. So the next way that you can offset, and this is going to be more useful in details that are maybe 1 to 10 or 1 to 5. When you draw a detail and you've got zoom line thickness on, what's actually happening down here, you're not actually sure. We really want to pull all of these things apart a little bit, and that's what this left component separation and right component separation is for. So with these set to 0, this is really squashed up and you can't really see what's happening. Whereas if we separate them, say, by 4 millimeters, it just separates every component by 4 millimeters. So we'll do it on the left by 4 millimeters and on the right by 4 millimeters. And suddenly, yes, there it is. We can see the bottom plate, we can see the lining, we can see the membrane, and we can see the tiles or whatever that is on there. And so it's very useful to be able to do that, to just pull things apart a little bit. even if it's just to show the line weights of things clearly, so that you get that little separation between the line weights so that the details are a lot easier to read. And the final thing I want to show is the ability to add description text. So right down the bottom here in the Object Info palette, we have this button that says Edit Description Text. And you can add some text that describes the left components, the center components, and the right components here. And you could pull those out into a schedule if you wanted to, or you can also pull that information out into a data tag. And if we just grab a data tag, and so here we have the data tag, the left component. So if I double click that, just go back to the drawing. So I highlight the object first depending on my settings up here. I've got it in single select object mode. So we click on the object, just zoom in a little bit, click on the object, and then that's going to pull out that description text out of the object. I could then pick the center component, click on that, pull that out, and then the right component. It's going to be a lot easier to find these if you've got the menu document, and this will be this one here. And let's just quickly put that in there. So that's pulling out the text out of this object, edit description text. And if you change the description text, then it changes here. If you double click this, tag data, click OK, it's a bit hard to see what we've got there, but I can edit this as well from the actual tag itself, and that's going to push the changes back out into the object itself.